Hi, I'm Dr. Vincent Macaluso. For those of you who don't know me, I'm a neurologist who specializes in multiple sclerosis. One of the main reasons I specialize in MS is because I've had multiple sclerosis myself for most of my life. I'm happy to say that the world of MS has been blessed with yet another medication to help slow down the course of our disease. The name of the medication is Ocrevus. The company that makes Ocrevus is Genentech. The purpose of this video is to educate people about this medication. It should be noted that I am the person producing this video. The makers of Ocrevus have no association with what is included in the video. I have received no compensation from Genentech, or anyone else for that matter, nor do I wish to. My purpose in making this video is to educate people about the medication. Additionally, I'm not your doctor. The only person who can say whether this or any medication is right for you is your personal physician. If you are looking for a neurologist and would like to make an appointment with me, my contact information will be posted at the end of the video. So let's get started with the show. For those of us in the world of multiple sclerosis, we should have a basic understanding of what MS is. For those who don't, I'll give you a primer on the topic. By the way, most of the images that I will be showing when teaching about MS come from my book, Multiple Sclerosis from Both Sides of the Desk. Let's begin with the nervous system. This picture is a drawing of what the human nervous system looks like. His name is Woody, and he is waving at you with his right hand. The human nervous system is made of two parts, the central nervous system and the peripheral nervous system. The central nervous system is made of the brain and spinal cord. This is the part that is affected by MS. The peripheral nervous system is made of the nerves that come off of the spinal cord and go to all the other parts of the body. MS doesn't happen there. It is the nerves in the central nervous system that are being attacked in MS. More precisely, one part of the nerve, called myelin, is being attacked. In this picture of a nerve, you can see the three main parts of the nerve. The first part is the cell body, which is the computer processor of the nerve. That's where the decision gets made as to whether the nerve will send out a signal or not. The last part of the nerve is the nerve terminals. This is where neurotransmitters are released from to send a signal to another nerve. The part in between is called the axon. The axon is a cable that connects the processor to the nerve terminals. The axon, like most electrical cables, has a coating around it. The coating around the axon is made of something called myelin. If the myelin is stripped away, the signal cannot go from the cell body to the nerve terminals. If the signal cannot be sent, then the command that your brain sends out never makes it to the place it was supposed to go. For example, if your brain wants to raise your right arm to get some ice cream or tofu or a bagel or whatever, the signal cannot get to the muscles in your arm and you cannot get what you wanted to get. The thing that is attacking the myelin is the body's immune system. Normally, the immune system is the system that protects our bodies from foreign invaders. Unfortunately, in MS, the immune system has turned against the body. In this picture, the immune system is represented by a white blood cell. A white blood cell chews up and digests the myelin, leaving the nerve demyelinated. No one knows exactly why the immune system decides to start attacking the myelin. There is a lot of evidence that if a person has the right genes and is exposed to something or some things in the environment, such as certain viruses, the immune system might develop antibodies that could start attacking the myelin in the central nervous system. No one knows for sure what the exact causes are. Since not being able to send messages through the nerves in the central nervous system causes a whole bunch of trouble, scientists, patients, doctors, caregivers, and a lot of other people have worked hard for many years to come up with medications to slow down the course of our disease. These drugs are called disease-modifying therapies. The way some of the disease-modifying therapies slow down our disease is by interfering with the attack on the myelin by the immune system. However, unlike this picture, the immune system is very complex. This picture gives a little better idea of what makes up the immune system. There are two parts of the immune system that are major players in multiple sclerosis. They are B cells and T cells. Our blood starts getting made from a stem cell that has the DNA programmed to make blood. There are two main cell types that it splits into, lymphoid and myeloid. There are different types of white blood cells that the lymphoid cell line makes. One of them is a T lymphocyte, which is commonly called a T cell. The other is a B lymphocyte, which is commonly called a B cell. The B cell is the cell that Ocrevus is targeted on. This picture demonstrates how Ocrevus works. Once Ocrevus gets into the bloodstream and sees a B cell, it binds to it. Once Ocrevus binds to it, the B cell sends out messages to other immune cells to destroy Ocrevus. However, when the other cells come to destroy Ocrevus, they also destroy the B cell. Each time a person gets a dose of Ocrevus, their B cells are wiped out. It then takes about 6 months to restore the proper number of B cells in the body. That's why the drug is dosed every 6 months. By taking Ocrevus every 6 months, the average number of B cells in the body is reduced. By having a lower average number of B cells in the body, the speed of attack on myelin is reduced. This is the way Ocrevus slows down the course of multiple sclerosis. Safety and efficacy. When a drug manufacturer wants to get their drug approved to help people, they first have to prove that their drug is both safe and effective in doing what they claim it does. In order to do this, they have to run studies. The studies have to have enough people in them to prove to the FDA that their drug is going to help more people than it hurts. The makers of Ocrevus did studies called Opera 1, Opera 2, and Oratorio. These studies proved to the FDA that the drug was safe and effective in slowing down the course of multiple sclerosis. Ocrevus was found to reduce the relapse rate by about 2/3. What does that mean? Let's say that you have MS, and you are not taking a disease-modifying therapy to slow down your MS. Let's also say you are having 1 relapse a year. Based upon the data in the table, over the course of 6 years, if you start taking an interferon, glatiramer acetate, or teriflunomide, you might expect to have relapses in 4 out of those 6 years. If you start taking fingolimod, dimethyl fumarate, alemtuzumab, or diclizumab, you might expect to have relapses in 3 out of those 6 years. Or if you start taking ocrelizumab, which is Ocrevus, or natalizumab, you might expect to have relapses in 2 out of those 6 years. In other words, Ocrevus slows down MS by about 2/3. Next, they demonstrated that the progression of disabilities that the people had in the study who were on Ocrevus was much slower than those who took Rebif. That means if you have weakness in your left leg, there was less of a chance that your weakness would worsen if you took Ocrevus than if you took Rebif. Third, it showed that people on Ocrevus had fewer gadolinium-enhancing lesions on their brain MRIs than people who were on Rebif. This is good since gadolinium-enhancing lesions are felt to be a marker of disease activity in MS. Fourth, it showed that people on Ocrevus had fewer new or enlarging lesions on their MRIs than people who were on Rebif. This is good since new or enlarging lesions are also felt to be a marker of disease activity in multiple sclerosis. So the fewer new or enlarging lesions you have, the better. Overall, Ocrevus's data shows that it is one of the best therapies in slowing down the disease progression in multiple sclerosis. At this point, it is crucial to remember one thing. The best therapy to help slow down your multiple sclerosis is what you and your doctor agree is the best medication for you.